So hello everyone, this is lecture 28 for the classical physics. In the last lecture we were discussing some questions regarding the Hamiltonian and the Lagrangian. So we were discussing some simple questions, means just a simple transformation from Hamiltonian to Lagrangian, and Lagrangian to Hamiltonian. So today we will see some tricky questions. Okay, so first we'll see again a simple question, that is h of a relativistic particle of rest mass m and momentum is given by this. Okay, we need to find the corresponding Lagrangian. So how you can find? So Hamiltonian given, then what you will do, just you need to remember these equations. These first two are for the Hamilton's equation of motion, and this third one is from the Lagrangian. Okay, so using of these three equations you can solve any question regarding this. So what you will do, you need to remove this p from here to get the Lagrangian. So you will use this equation, x dot equal to del h divided by del p. So find this relation. So now you can write p in terms of x dot and just substitute here. So what is x dot? Del h by delta p. So differentiation of this with respect to p, it will give you 1 upon 2, and this will be your differentiation, 2p upon this side. So 2 will cancel out, this will be this. Now you can solve this equation, this will be here, then you will get p square x dot square here, then taking p square common and finding the value of p in terms of x dot, that will give you this. P equal to x dot m divided by under root 1 minus x dot square. This is a simple calculation, you can do this. Now you have p in terms of x dot. So you use the formula, the conversion formula. L is nothing but p x dot, means sigma there was, so but there are only one variable, so it will be p x dot minus this complete Hamiltonian. So this is your Hamiltonian under root p square plus m square minus vx. So this will give you your Lagrangian. Now in place of p, you will write this value, so that will give you Lagrangian. So x dot m will give you x dot square m divided by under root 1 minus x dot square, and here also remove this p with this value, so this will give you this. Now simple mathematics, you can solve this, multiply it here and resolve it, it will give you this. Now taking the under root 1 minus x dot square common, it will give you 1 minus x dot square above, so it will give you under root, one under root will cancel out, and this will be 1 minus m under root 1 minus x dot square minus vx. So this will be your Lagrangian. So that's how you can solve this question. Now let's see this question. A particle of mass m is constrained to move on a surface of cylinder radius r. The particle is subjected to a force directed towards the origin and proportional to the distance of the particle from the origin, its h will be. So we have solved this kind of question, but for the Lagrangian. So what is this? This particle is restricted to move on the surface with radius r of the cylinder, and we know how to find this Lagrangian, but this time we need to find the Hamiltonian for this kind of motion. So if you know the Lagrangian, then you can directly find this Hamiltonian just using these things, as we already discussed how to find the Hamiltonian. Just you need to find the relation between x dot and p, then substitute in place of x dot whatever you are getting, the p. Okay, for the Hamiltonian, means you will use this relation, then you will get p in terms of x dot. So at x dot will give you something in terms of p, then substitute in place of x dot the p terms, that will give you Hamiltonian. You know this conversion, I am telling you again and again the same thing. Now this F is given as it is central force towards the center, so if it is minus kr, we can write it in this form. So V is nothing but k square F dr minus F dr, that will give you kr square by 2 here, just a simple integration. This is your potential energy, and kinetic energy for this particle will be half k, and r dot square, the speed square. So speed is nothing but this r dot is sum of r dot square equal to this r square plus this z square. So in place of this we can write, means in place of this r square we can write r square plus z square. So this is your potential energy. Okay, now see here, this Hamiltonian will not be, means this potential is not the function of time, that's why and the velocity. So we can write the, means here what is the thing, means constant of motion will be total energy for the Hamiltonian. Okay, means total energy will remain constant, and that will be kinetic energy plus potential energy. Means now we can write our Hamiltonian in terms of sum of potential energy and the kinetic energy, because this potential energy does not include any velocity term, or it is independent of time, it's not a function of time explicitly. Okay, so you can write the kinetic energy will be this thing, because one of the thing, that is this s, there are three components s phi z. So this s dot will be 0 because this r is not changing, so that's why we have only two components for velocity, and these are the two kinetic energy for the phi and the z, and this is your potential energy from here. So this will give you Hamiltonian, because means you need to find Hamiltonian, that's why. So you can write this form. Now see, you are getting here pz square by 2m, but here you are getting p phi square divided by 2m r square. So hope you know how to find this kinetic energy for phi, because this is nothing but is same as, let me tell you, here you have this cylindrical type of system. When you write this Lagrangian for this kind of system, this was this, means velocity was this s phi dot. Okay, then s square phi dot square will give you v square for phi, v phi. Now see, to convert this, what you will do, in place of phi dot we need to write p phi. So for that, p phi is nothing but del L by phi dot. You know this relation. So del L by phi dot will give you ms square phi dot will equal to p phi. From here, phi dot will be p phi divided by ms square. Now to convert this in terms of p phi, you will write in place of phi dot, what you will write, p phi divided by ms, means p phi divided by ms square is nothing but phi dot. So this will give you phi dot square divided by m square s4. So 1 m will cancel out, and s square will give you, s square will cancel out, and s4 will remaining to s square only. So what you will get again? So this kinetic energy in terms of Hamiltonian will be p phi square divided by 2m r square, because in place of s this will be r. So I hope you get this idea, because we need to remove that phi dot term, so we can remove this with this help, because this you can use this relation here. So we are using this relation here. P is nothing but del L by del q dot. So for p phi it will be del L by q phi dot. Okay, so use this relation in the previous one, and you can find the value of p phi. Okay, means this phi dot, and you substitute, then you will get this relation. So this will be your kinetic energy for the phi angle, and this is for z. And for r, I already told you this is constant, that's why this r dot will be 0. So you will get only these two components, and potential energy will be this. And Hamiltonian is nothing but sum of potential energy plus kinetic energy. So this will be your Hamiltonian, you can find directly. I hope you get this idea, because this is a very helpful concept here. Now let's see the next question. Consider the Lagrangian is given 1 minus under root 1 minus q dot square minus q square by 2 of a particle executing oscillation whose amplitude is given is a. If p denotes the momentum of the particle, then we need to find the value of p, 4p square. So what you need to do here, so to find this one, first you need to convert this into the Hamiltonian, only then you will get p something in that. So you know how to convert Lagrangian into Hamiltonian. You need to find what? First you need to find a relation between p and q dot, then in place of q dot you will write p. So for that we need to find p equal to what? P equal to del L by q, del q dot, we know this relation. Now L we know from here. Now differentiating it with respect to q dot will give you this, q dot divided by under root 1 minus q dot square. Now from here you can find the q dot relation with respect to p, means q dot in terms of p, just it will be here, then q dot square divided by p square will give you 1 minus q dot square. That's how you can solve this for q dot equal to p upon under root 1 plus p square. This is a simple calculation. Now you have q dot in terms of p. So Hamiltonian is nothing but pq dot minus Lagrangian. So Lagrangian is this. So I have written it here. Now everywhere wherever you are getting q dot, you will write this term. So you will get this relation. Now you can solve it simply. 1 plus p square will be here. It will give you under root 1 upon 1 plus p square. Then you can solve this taking the under root 1 plus p square common, or the LCM. And now see, this Hamiltonian is, you can see that potential energy is not a function of time here, because from here you can see, from Lagrangian, this is your kinetic energy term, this is your potential energy term, and potential energy is not a function of velocity or time. And that's how you can write Hamiltonian, means your Hamiltonian will be constant of motion. So you can write Hamiltonian as total energy. So we can equate this with the total energy. And what will be the total energy for the oscillations? So energy for our oscillation is nothing but potential energy plus kinetic energy. So kinetic energy plus potential energy is kx square by 2 for a simple harmonic oscillator. Now see, amplitude is given, that is a. So when oscillator is at its amplitude, then its velocity will be 0, because at its maximum value kinetic energy will be 0. So this term will be 0 at x equal to a. So energy will be equal to k square divided by 2. Now this question was asked in the previous year, and they assume k as 1 here, means they proportionate E with a square by 2. Only then you will get this answer. So k will be 1 here, so energy will be a square by 2. So a square by 2 just and this Hamiltonian is total energy, so we'll write in place of Hamiltonian, that is a square by 2, and we will equate this with this energy. Now you have this relation, you can find the value of 4p square from here. You need to find this 4p square, you can find this from here. How? Just a simple calculation. This will came to this side, and this is also came this side, 1 plus p square this side, and solving this, then squaring both sides will give you this thing. Now opening this square will give you these things, and 4 plus 4p square, 4 will cancel out, then you will get 4p square equal to this. Now you just need to simplify this simple calculation, and you will get this thing as your 4p square. So this will be your answer. So you are getting this answer only when this uk will be 1 here. Okay, so that's why we conclude that in the question they assume the k equal to 1. So this was a little bit tricky thing. Let's see some more type of questions. The Hamiltonian of a system with generalized coordinate and momentum q and p is this. Hamiltonian is given. A solution of the Hamiltonian equation of motion is. So we need to find the solution. So there were 4 options in this question, and in options it was given like this kind. Means in A option p and q was given, then in B option p and q was again given. In terms of t, means these functions were given in the options. So by seeing options you can find a very good way to solve the question, because here we are seeing that we are finding a relation between p and t and q and t in all the options. So what we need to do is we need to find dp over dt. So if we can find dp over dt or dq by dt, then we can find a relation. Means we can find a q function, means fq function we can find, and that is this, and we can find a fp function that is only depending on p. Okay, so we can find this, and that is giving us this thing. So to equate these options, first we need to find these things. So how we can find these now? This is nothing but q dot, this is p dot. So q dot is nothing but, from the Hamiltonian equation, you know, this is del h by delta p. So you have h, and del h by delta p will give you 2p q square. So dq by dt will be 2p q square, and the same from the second relation, p is nothing but, p dot is nothing but del h by minus del h by del q. So it will give you minus 2q p square. So you have this relation now. Now see, you need to find relation between q and p, because to solve this equation you need to get something here which is only depending on q, and here which is only depending on p. So you need to find a relation between p and q, so that you can substitute in place of p q and in place of q p. Okay, so you are getting these things. Now you can find dividing these, dp by dq can be find it from here. So dp by dq will be divided, means this will be divided by this, will give you minus p upon q. Now see, dp by dq will be minus p upon q. Now this can be solved by using separable method. Okay, separation of variable. So p will go this side and dq will go this side. So simple integration, this will give you log p, this will give you log q, and some constant, we assume it log a. Okay, now this will go this side, and pq, log pq will be log a, so pq will be a. So this is our first relation between pq, this is a. Okay, so you have now relation between pq and a. Now see, you already find q dot. Q dot is 2pq square, but to solve this relation, you need to find what, p in terms of q, so that you can directly solve this. So from here you can see that p is nothing but a by q, or here this dp by dt is minus 2q p square. Okay, so here you need to substitute q in terms of p. So q is a by p. Okay, so in place of q we will write a by p, it will give you minus 2ap. So dp by dt is nothing but minus 2ap. Now from here p will come this side and dt will go this side. This is a simple integral again. This is log p equal to minus 2at plus some constant log b. Now see, this will go this side, and you will get p upon b equal to minus 2at. So p upon b should be equal to exponential minus 2at, only then this log will give you minus 2at here. Now from here you can find this p is equal to b exponential minus 2at. So that was your option, means you find it the p in terms of this. So p was b exponential minus 2at. Now you need also to find q also. So you have relation between p and q, that is a. So q is equal to a upon p. So a over this p will give you a upon b. This will go to the upside, will be positive here. So you can find directly q from this relation. So just understand this concept, that what we need to find, and what is the relation between time and q. So that's how you can solve this question. Okay, so you need to understand the concept very much clearly, and see, we are using only those 3 relations I already give you. Okay, so we are just playing with them. Let's see one more question. The h, or Hamiltonian of a particle of unit mass moving in xy plane, is given by this. So Hamiltonian is given for the xy plane in suitable units. Initial values are given to be for x at time 0 and y at time 0 is 1 1, and same for px at time 0 and py at time 0 is 1 by 2 1 by 2. This is py, not py dash. Okay, so what we need to do, during the motion the curve traced out by the particles in the xy plane and pxy plane are. So we need to find a curve which is traced in the xy plane and a curve which is traced in px py plane. Okay, so to find the curve, what we need to find is relation between x and y. Only then we can say how it is going. And same, we need to find the relation between px and py. Only then we can say that how the curve is going. So to do this xy relation, we will use the same method we did here. Means here we find the relation between p and q. Here we will find the relation between x and y. So we use the same method. We will find the x dot first. X dot is nothing but del h by del px. So del h by del px will give you x from here. So this x dot is x. Now find the y dot. Y dot is nothing but del h by del py. It will give you minus y. Now from here you can find the relation between x and y. See how. Dt will go this side, x will go this side. So log x will be t plus some constant. Now we use the initial conditions. At 0 it will be 1. So put t equal to 0 and x equal to 1. It will give you 0 here. C1 will be 0. So x is nothing but exponential t. Similarly, you can find this relation for y equal to exponential minus t. Now see, we need to find the relation between x and y. So multiply these two things. xy equal to et multiply exponential minus t will give you 1. So xy equal to 1. So we find the relation between x and y. So seeing this, y equal to 1 upon x, this is nothing but relation of hyperbola. So that's how we can say this. Now same we will do for this px py, and we see the how this graph will be. Means we will find the relation between them. So how you will do that? We will use the second equation for Hamiltonian. That was px dot and py dot. That was minus del h by del x minus del h by del y. So it was just same. Will totally same. We will do the same procedure. Okay. So px dot is minus del h by del x. So we will solve it from here. Del h by del x will give you px, and from here it will give you x minus x. So you will get this del px by del d. Px dot is nothing but minus del h by del x. That will give you minus px plus x. Okay. Now see, this is equal to this. Now we already find this value of x, that was x equal to exponential t. So substitute here. So because we need to find the relation between px and t and py and t, that's how we can find the relation between px py. So we'll do the same. Now this is equal to exponential t, so we'll take this side. So we are getting this equation. Now multiply with exponential t in whole equation. So et exponential 2t. Now see, we can write this relation in form of this, because applying the product rule on this, it will give you exponential t then dpx by dt plus etpx. So we can write this whole thing as this. Now see, we can separate these things. I mean dt can go this side, and etpx will be equal to integral of this, and that will give you exponential 2t divided by 2 plus some constant c1. Now you will apply the initial conditions. That was at t equal to 0, the px was 1 upon 2. So at t equal to 0, it will give you 1 upon 2 plus c1. Here also you will get 1 upon 2, and t equal to 0, this will be 1. So 1 upon 2 will cancel out, c1 will be 0. So that's how you will get px equal to exponential t by 2, because this 1 exponential t will cancel out this 1 exponential t, and px will be exponential t by 2, and this is 0. That's how you find this. Now same we will apply for py dot, and py dot will be del h by minus del h by del y. That will give you py minus y. Now see, you know the y is nothing but minus exponential minus t. Sorry, this is exponential minus t. So you substitute here again. This will go this side. Well, this is not going anywhere. Just multiply with exponential minus t in the whole equation. So you will get this equation. Now you can write this again in the product form. Means you can just use this product rule here, and you will get this relation. To simplify this, we can write this equation in this term. Use the product rule, you will get again this. Now this dt will go this side and integrate both sides, will give you py exponential minus t will be equal to minus exponential minus 2t divided by minus 2. So that will give you this and this. Then after solving this, 1 exponential minus t will cancel out this term, means one term from the 2t, and it will give you exponential minus t divided by 2. So after solving this, you will get this py equal to exponential minus t divided by 2. Now you have py in terms of the t, and you have px in terms of t, and you just multiply px py. This exponential term will cancel out each other because it is minus t and plus t. Give you exponential 0 will equal to 1. So it will give you px py equal to 1 upon 1 by 1 upon 2 will give you 1 upon 4. Now you have relation py equal to 1 upon 4 px. That is again a relation of hyperbola. Okay. So that's how you can solve this type of questions. Okay. Let's see one more question. Hamiltonian is given h equal to px square plus x square, and initial conditions are given. X at t equal to 0 is a, and x dot at t equal to 0 is 0. we need to find xt. So we need to find x in terms of t, so we need to get some function, means in terms of x and time. So how we can do that? We use the same relations. First, x dot is nothing but del h by del px, so it will give you 2px here, and px dot is nothing but del h by minus del h by del x, it will give you minus 2x from here. Now see, x double dot from here will give you 2px dot, x double dot will give you 2px dot from this relation. Now in place of px dot we can substitute this, so we get a relation which is depending on x only and t. So we did this thing only to get a relation which is depending on x and t only. So that's how we can find a relation between, means we can find a function which is depending on t only to get this. So that's why that was the aim to do this. Now we have x double dot plus 4x equal to 0. So we can use the differential equations things here to solve this. This is a homogeneous second order differential equation. You can see my lectures on differential equation to solve any kind of differential equation. So solution of this equation is nothing but x equal to c1 sin 2t plus c2 cos 2t. Okay, so from here this is x. Now you can use it in the initial conditions. At t equal to 0, t equal to a. So at t equal to 0, this will be 0 and this will be 1. So c2 will be x equal to a. So c2 equal to a. And you will use the second condition now. X dot at t equal to 0 is 0. So find the x dot. Find the x dot from this relation, means in place of c2 put a. Then x dot will be sin 2t will give you cos 2t and 2c1, and here you will get cos 2t will give you minus sin 2t and 2. Now placing in place of t equal to 0, it will give you 2c1. 2c1 equal to 0, so c1 will be 0. So you will get c1 will be 0, then x will be a cos 2t. So xt is nothing but a cos 2t. So this will be your answer, because this was the required question. Okay, now let's see one more question, the last question for today. A particle of mass m is free to move on a frictionless horizontal 2D r theta plane. So it's a 2D plane, r theta polar plane, and it is acted upon by a force. So force is given with k being a positive constant from here. This is again a central force. If pr and p theta are the generalized momentum corresponding to r and theta, then we need to find a dpr over dt. So we need to find pr dot. So how you can find pr dot? So you know the relation. Pr dot is nothing but del h by delta r. So if you know that you can find this relation from the Hamiltonian. So what is your aim? To find the Hamiltonian first. Only then you can find this relation. Now see, this is a relation where, means you can see from this force that potentially will not be depending on time or velocity. So it is again a, means Hamiltonian will be a constant of motion. So you can write total energy as Hamiltonian. Okay, so you can write directly here that p square by 2m plus p theta square by 2m square plus vr as your Hamiltonian. Okay, so I already given this example, this kind of example. So why we write this p theta square by 2m square, I already told you this also. So let me give you here again explanation. So you know how to write Lagrangian in the polar coordinates, that is half m r dot square plus r square theta dot square minus vr. So I already told you how to write this. This is kinetic energy, this is potential energy. Now see, when you convert Lagrangian into Hamiltonian, you use this relation pr equal to del L by r dot. So you will get from here, this is mr dot. Now you will write r dot in terms of pr. So r dot equal to pr over m. Now you have this relation, same for theta. P theta equal to del L by del theta dot. That will give you mr square theta dot. Now theta dot will be phi theta by mr square. Now in place of theta dot, you will write this p theta by mr square. So it will be p theta square divided by m square r4. So it will give you, m will cancel out. It will give you p theta square divided by m r square. Okay, so that's how you will get this term, p theta square divided by 2m r square for the kinetic energy of theta value, and for r it is pr square by 2m. So that's how you get this value. And the previous example also, where we were discussing about the cylindrical coordinates, there also you get this term same likewise. Okay, there it was s square phi dot square. So in place of s it was r, capital R. So that's why you get that there, this capital R. Now you have Hamiltonian, you can find this pr dot. Pr dot is nothing but del h by del r. So find the del h by del r from here. So this is not depending on r, so this will be 0. And from here you can find a simple differentiation. It will be r square here, so it will be minus 2 divided by 1 upon r cube. So minus 2, and you know it is minus del h over del r, so minus will cancel out. So you will get p theta square by divided by mr cube after differentiating this. And this is then minus del v over del r, because we are differentiating whole term with respect to r. This is minus del v over del r. Now see, this minus del v over del r is nothing but force, and force is already given, minus k over 2r cube r cap. So use this thing directly, because this is your force, you know this thing. Minus del u or del r is force. So in place of this, I will write this value, and this will be your answer, because this is PR dot, and that was the needed, means this was the needed answer. So this will be 2 p theta square minus mk divided by 2 mr cube. So this will be your answer. So that's it for today. I hope you understand the today's lecture. If you are having still any doubt, put in the comment section. I will try to resolve. Thank you everyone.